Okay, so in this next section, it says to add or subtract the following radical or complex numbers. So these are very similar, both of them, to adding variables. So when I have 4 root 11 plus 2 root 11, the root 11s have to be the same, and they are. So then all I have to do is add or subtract the coefficients. So 4 plus 2 is 6. So the answer is 6 squared root 11. Very simple. On the next problem, I have a subtract. Because I have a subtract next to a parentheses, that reminds me that I need to distribute. And then I'm just going to combine like terms. My 9 and the 2 add together to get 7. The 4i and the plus 6i get 10i. The only thing you have to remember is that the I needs to go in the back. In order for this to be an a plus bi form, the real number 7 has to go in the front and the imaginary 10 has to go in the back. That's the only tricky thing about that. But it was already in that form, so if you just continued it to leave it in that form, then you'd be good. In the last section says to simplify the following radical expressions. So this is in to try to get us ready for the next unit. So we have root 27. I need to worry about the square root first before I can reduce anything else. So I'm going to come down here to the side and break that down. That's 9 and 3, 3, 3 and 3. So this looks like negative 12 plus or minus. The square root of 27 turns into 3 root 3 over 15. At this point, I'm going to look at all of the coefficients on the outside, the negative 12, the 3, and the 15. Each of those coefficients can be reduced by a factor of 3. So I'm going to divide each by 3. So negative 12 divided by 3 is negative 4, 3 divided by 3 is 1, and then 15 divided by 3 is 5. So that gets me negative 4 plus or minus 1 square root of 3 over 5. I do not need to break this up because there is no I. If there was an I would really need to break that up into 2 fractions, but there's not, so I'm not going to do that. If you wanted to, you're welcome to. You could break it up, but it really doesn't look any different or better. It's just broken up into 2 fractions. On the next problem, I'm going to work the square root of negative 63. Okay, because there's a negative right in the beginning, I know that there's an I. So let's just focus on 63. That's 7 times 9. 9 is 3 times 3. So the 3 goes out. The negative comes out and becomes an I, and square root of 7 stays out. Stays inside. So I have 9 plus or minus 3i root 7 over 6. Okay, at this point, the 9, the 3, and the 6 all have a factor of 3 in it. So if I divide each of these by 3, 9 divided by 3 is 3, 3 divided by 3 is 1, 6 divided by 3 is 2. So that leaves me with 3 plus or minus 1i root 7. Now I'm not going to put the 1 there because you don't really need to. All over 2. Now, because this one has an I have to write it in a plus bi form. So in order to write it in a plus bi form, I have to break this up into 2 fractions. So 3 halves plus or minus I root 7 over 2. This is the acceptable way of writing this problem. Whereas number 29 could have been written another way, number 30 has to be broken up because of the I, and it has to be written in a plus bi form. All right, last problem. Root 16. Square root of 16. I know 16 in my head. The square root of 16 is 4. So that means the square root of negative 16 is 4i. And in this case, 10, 4, and 2 all have a common factor of 2. So if I divide each by 2, 10 divided by 2 is 5, 4 divided by 2 is 2, and 2 divided by 2 is 1. That gets me 5 plus or minus 2i over 1. But no one writes over 1, so we're just going to write 5 plus or minus 2i. And that already is broken up into a plus bi form. So I don't need to do any more breaking up because it's already there. And that concludes this lesson for Practice Exam 3. So good luck on your exam, guys.